we're given this situation that the marginal cost function, now the marginal we know is the derivative, so here's the marginal given by that linear function, and in fact the slope is negative, right? So you've got a downward line, where x represents the level of production, so x is the level of production, and c prime of x the marginal cost. And what we want to do is try to find and try to determine the cost function. C, all right, we can get c, right, by integrating c prime. Okay, so and then we're given this initial condition. If the production level of 100 items, the cost is this number right here. So part A, we just want to compute the derivative at 590. All right, so this is just a straight plug-in problem. So we're going to have a C prime of 590. This is going to be negative 0.04 times 590 plus 30. Okay, I did that on Wolfram Alpha, and I got 6.4. Let's just stop for a minute and reflect on what it means. If our level of production right now is 590, to produce that next item is going to cost us 6.4, right? 6.4 over 1. So as we increase production by 1 from 590 to 591, the cost will increase by about $6.4. Now in part B, what we want is actually to get c of x. So c of x, that's going to be the integral of c prime of x with respect to x. So what we're going to do is we're going to integrate negative 0.04x plus 30 dx. This will give us negative 0.04, x squared over 2, right, plus 30x, and then don't forget our plus c. So there's c of x. We can simplify it a little bit right here, right? What we can do is divide 0.04 by 2. I'll do it up here. So c of x is negative 0.02 x squared plus 30x plus c. By now we have an initial condition, so we need to get this value of c. So we know that when x is equal to, so what does it tell us up here? Let's see, if at a level of production of 100, so when x equals 100, c of x is equal to that 7255.00. So let's put that number in right up here, right? We'll put the 100 right in here and here, and the 7255 right over here. That's going to give us 7255 is equal to negative 0.02 times 100. I'll put it like this, times 100 squared plus 30 times 100 plus c. All right, so my calculator, I'm getting 7255 equals, now this part right here, when I did that on my calculator, I got 2800 plus c. So if I subtract that 2800 now, I get c equaling 4455. Okay, so I'll do this way up here at the very top over here. So here's what I'm getting from my cost function. The cost, depending on x, the level of production, is, where are we? I'm going to look back in here and replace that c. So this is negative 0.02x squared plus 30x plus 4455. There's the cost function. And then in part C, we want the cost at 590. So what we're going to do, of course, is just put that 590 right here and compute. And that was simple enough. I did that on my calculator. I got 15193. And I think it's all in dollars, right? Okay. $15,193 to produce 590 items. So if we look back here and get a big picture of everything, the cost to produce 590 items would be $15,193. And then if you look at the derivative, The derivative is this 6.4, so if we increase production by 1 unit from 590 to 591, the cost would go up by 6.4. So what we would get here is like plus 6.4, so we're looking at what, 199.4 for that would be the cost of 591.